Question 23. Pendulum bob is suspended by a 2.4 meter long string. When the pendulum is pulled sideways, so it makes an angle of 14 degrees, the restoring force is 9.5. What is the mass of the pendulum bob? I don't think we need to go over this in any great detail at all. It's this question here. Sine theta equal, well, let's just write it like this. The restoring force equals sine theta mg, and in this case, we're just solving for m. M equals the restoring force times the sine of theta times g. There's your restoring force. There's your angle. Gravity 9.81. Straightforward, and the answer is number 23C. 24. We've got a horizontal spring system. The mass has a spring constant of, this one is the maximum speed. Okay, so here's one that we haven't seen. We have a mass on a spring with this spring constant here. And this displacement. And we want to know the maximum speed. So I don't think we need to go through the entire derivation of this formula, because if you have to do this on a test, then it can take a little extra time. But you will recall that we derived the formula for the maximum velocity of a horizontal spring, and that formula is A times the square root of k over m, right? And where did we derive that formula from? We derived that formula from the conservation of energy. So if you want to know how to derive that formula, just go back to your notes, and you can see how we derived that formula. Once you know that, and remember A is the maximum amplitude, or it's just the amplitude, and so that actually is your x value. So it's just a matter of plugging the numbers into that formula there. And if you want to know how we derive that formula, just go back into your notes, find out the derivation. Otherwise, it's just one of those formulas you'll want to memorize. The answer turns out to be B. B. 25. On planet M, a pendulum. It's another one of those ratio questions, which I really like. I like these ratio questions. It's probably far more important for you to be able to do these type of questions when you get to university level physics than do the questions where they just give you hard and fast numbers and you plug them into a formula. Relationships, they're always more important than everything else in physics and in interpersonal. That was a good life lesson. Planet M has the pendulum is a length m and has a period of 2. Okay, so we're dealing with the periods of pendulums. And the formula for the period of a pendulum is this one, 2 pi times the square root of L over G. It's on your formula sheet. Which of the following is true? Okay, so on M, we have a length of L and a period of T. On N, we have a pendulum that has 6L and 3T. Which of the following is true for the ratio of the acceleration due to gravity? Okay, this would be a standard of excellence question, because the first thing you have to do here is solve for G. So you have to rearrange the formula, solve for G, and then and go from there. So let's do that quickly. Remember, if you're solving for a variable that's under a square root sign, the first thing you're going to do is square everything. T squared equals 4 pi squared LG. That's squaring everything just has the function of eliminating that square root sign. And then you can move your G up here, over to here, And move that down there, and you're going to get G equals So that's that formula solved for G. Now you can go back to the question. And let's do M first. So M has a length of L and a period of T. And again, this is great because they don't give you numbers. They just give you variables. So if the length is L, we're just going to call it 1. And if the period is T, we're just going to call that 1. So if I'm doing an expression for the gravity on M, I could do it like that. Now, we really want to do this as efficiently as possible, so I'm going to also acknowledge that 4 pi squared is a constant. So since it's constant to both things, it's going to appear in the gravitational acceleration due to gravity for m and for n. It's just going to cancel each other out. So if I really want to be efficient about this, I'm just going to erase this so I can be near to the mic. I'm just going to write it like this. 1 over 1 squared, which equals 1. How easy is that? And then when I do n, again, I could do it like this. It has 6 times the length and 3 times the period. 6, 3. But since these just cancel out, then just to make things nice and simple, I'm just going to say 6 over 3 squared, which equals 6 over 9. All right, and then I've got to simplify it into one of these. And we want m on the top and n on the bottom. So actually, we've got it right there, don't we? Right there, right there. 1 over 6 over 9, which is going to reduce or simplify to 1 times 9 over 6, which equals 3 over 2. Great question. Number 26. A wave in a spring stretched to a length of 3.5 travels at 5.3 travels at 3.4. What is the lowest resonant frequency for this spring? Okay, you have to think about this one a wee bit. So we've got a fixed spring. So if it's a fixed spring, what's the shortest wavelength that will fit in within that fixed spring? And the answer is 1/2 of a wavelength will fit within that spring. And that's kind of important because the spring is stretched to a length of 5.3. So if it's 5.3 and 5.3 meters represents half a wavelength, then one full wavelength must be 10.6. So we got a full wavelength is 10.6. We got the speed. We just want to know the frequency, use the universal wave equation. And that's going to give you an answer of B. 3.12. Okay, let's move on to all of this done. Again, 27 is not one that I'm going to go over with great detail. It's a restoring force question, pendulum here, restoring force, angle, which turns out to be what they're asking for. FG here, the restoring force, well, let's write out it. Sine theta equals the restoring force divided by Fg. It gives you the restoring force. Gives you the mass. Do that mathematical operation and then inverse sine of the answer to get the angle, which turns out to be, where's my answer? 18.8 degrees. (28). 28, we've done this one a bunch of times too. We've got a simple harmonic oscillator oscillating with an amplitude, so the x value is 7.5. The spring constant, 2.25 times 10^3. The maximum acceleration is 25.7. And we want the mass. Right, we've done that question a number of times. Plug the numbers in, get the mass, and it turns out to be 6.57 kilograms. (28), 29. How many more? 29. A 1.25 long pendulum is set up on a planet in which the acceleration due to gravity is 6.84. The period of the pendulum. The period of the pendulum is this formula here. That's a very straightforward question. They've given you the length. They've given you the 6.84, plug the numbers in, answer turns out to be 2.69. Number 30 is the same type of question, but this time they're asking for the acceleration due to gravity. So this time they give you the length, they give you the period, and they want to know G. So if you rewind the video, you can find out how to solve for G. Solving for G, what did it turn out to be? 4 pi squared. Don't forget to square the pi, L over T squared. You got your L, you got your T, you got your 4, you got your pi. Plug the numbers in, ends up being an answer of, oh, I can't even read my own writing. That is tragic. See if I can find the answer somewhere else. 20, what question are we on? 30? 20.5. 20.5. Ooh, 20.5, that is a big planet. Or a very dense planet. Yeah, I wouldn't want to hang out there for too long. Number 31. A sound wave has a speed. What? Did we miss a question? Oh, no, we didn't. No, sound wave has a speed of 335 meters an hour. The frequency of sound is 256. What is the wavelength? Really simple. Speed, frequency, wavelength. Universal wave equation. Divide the two numbers, 1.31. Is the answer number 31. All right, here we go. Okay, here we go. I was rushing through that so I could get to this one. This is the one we're going to want to spend a little more time on it. Well, the video is getting long. Let's stop. I'll make one more video just so I don't have to rush through this question. Okay, so go to the next video for the answer for this.